This is my second video on analyzing graphs of functions. In this video we're going to focus on finding the zeros of a function, specifically graphically, but we're also going to visit algebraically. So very quickly what I want to start with is, what is a zero for a function? And what we say is a zero is any x value that when we plug it into the function makes this statement true. That is, it is an x value that gives us a y value of 0. So graphically speaking, when we look at this graphically in just a moment, we're going to say that given a function, its zeros would be any x values that our function would be on the x-axis. They would be y values of 0 at those given x values. So in order to find the zeros of a function, you'll notice that I have a function here, f of x equals x times the quantity x minus 7. What we're going to do algebraically is we're going to set equal to 0 and solve. And this is how you would do this with any function, but essentially what we're going to do is we're going to take this f of x value or y value, and we would say, let's go ahead and allow it to be 0, and then we're going to go ahead and solve for what x values will make this true. Now this is actually a good algebra review. As a matter of fact, you'll notice here that this is already a factored expression. That is, something times something. We have factors here in a product. And one thing we know is this: if you were to multiply two factors in a product, say a times b equal to 0, what this would imply is that either a is equal to 0 or b must have been equal to 0, or they both were. And the beneficial thing to this is, when we set a complex, I don't want to say complex in terms of complex numbers, but a more complicated algebraic expression equal to 0 to solve it, our goal is often to factor it, because what we can do is we can just go ahead and take each of these individual factors and set them equal to 0. So we'll say, well, then either x was 0 or x minus 7 is 0. And in this case, you'll notice that x equals 0, we don't need to isolate x. In this case, over here, however, we would need to add 7 to both sides of this. Really easy to solve. And we say, well, then x must be 7. And really quickly, what I'd like to do is I'd like to just go ahead and show everybody that if we were to insert both of these values into the function, that is, plug in 0 or plug in 7, then what we would get is an expression that says 0, 0 minus 7. We plug in zeros for x's, and you'll notice that it doesn't matter that this gives us a negative 7. All that matters is that we had a 0 in this product, and it wipes the whole thing out, and we get an output of 0. So 0 is a 0. Also this, we'd say that if we were to plug in 7, we get 7, 7 minus 7, we get 7 times 0, which is 0. So 7 comma 0. So we would say that these two x values are considered to be zeros of the function. We're also going to call these solutions. We also call them roots, okay? But most importantly, we need to know that a 0 is an x-intercept, okay? So bringing up this graphical approach then, saying that a 0 is an x-intercept, what I want to do really is to show you that if I had a function such as this one here, x times x minus 7, graphically how we would find its zeros. So what we are going to do is we are going to get out our calculators here, and I have a TI-83 emulator. Here's what we'll do. Graphically, what we're going to start with is we're going to push the y equals button, which is this top left button here. You'll notice it also says F1, kind of like the F keys on your calculator or your computer. But we're going to put this function in, and your x key is this one right here. It says x comma t comma theta comma n. But we're going to say x, and then I'll put a parenthesis, and we say x minus 7. Let me get that minus in there. Minus 7. And end parenthesis. And the next button we're going to hit here is graph. So I want to go ahead and take a look at this graph, and you'll notice that when I look at this, we have this parabola here, but looking at where its x-intercepts are, I notice that when x equals 0, we have a y value of 0, and when x equals, if you were to count this, 1, 2, 3, 4, 5, 6, 7, at x equals 7, we have a 0 as well, okay? So the whole point of this was to show you graphically how we can find zeros. Well, we can identify them visually, but sometimes they're going to be a little bit sticky, you know, maybe some decimals. So what I would like to show you is that we're going to press calc and then select the 0 function here. And I don't mean function in terms of, these functions over here. I mean like an operation that your calculator goes through to find the zeros, okay? So what we'll do is we'll find the calc, which is behind this trace key right here. So you have to hit second trace. You'll notice that 0 is the second option down. You can also just hit 2. When I click on this, it's going to say select a left bound. Now what this means is if I want to find what is the 0 right here, if I didn't know it was exactly at x equals 0, it's saying go somewhere. Let's scroll to the left of that 0. You'll notice that my cursor, try to show you here, this blinking cursor moved to the left of x equals 0, and I'm going to hit enter. And I want you to see this little arrow is basically saying, dear calculator, the 0 that I'm looking at right here is to the right of that x value that I just selected. And we're also going to scroll to the right now. It says select a right bound. So I'm going to go to the right here, and you'll notice that I've also dipped below the x-axis here. So of course there must be a crossing point there. I'm going to hit enter. And it says, okay, well, basically, calculator, the x value is between these two x values right here. And then it's going to say guess. And so I'm going to scroll back over, and as close as I can get to 0, maybe right here. I don't have to be that close. I'm going to hit enter. And what it'll do is say you have a 0 when x equals 0. Y equals 0 when x equals 0. Likewise, I could run through this very quickly. We'll say second calc, we'll go to 0 again. And instead, this time, we'll find the 0 on the right. So it says select a left bound. I'm going to scroll to the left, somewhere to the left of this 0 on the right, which is at x equals 7. I'm going to say right here. And then it says select a right bound. We're going to go somewhere to the right of that 0. And then again, we're just going to kind of try to guess where it's at. Maybe right in here. I can't get exactly on 7. It's close, but I hit enter. And again, it says, well, you have a y equals 0 or a function value 0 when x equals 7. So graphically, we say the zeros of our function are the x-intercepts, and we find those on the calculator by using the calc 0 option. Cheers.